Hello, everybody. This is Shad here in another edition of Near Workshops. Pretty excited to have actually one of the first indexing workshops with Sean from SubQuery. So if you don't mind, I've taken it away and yeah, showing us how it's.
Awesome. Thank you so much for that shot. And again, welcome everyone to the virtual workshop on data indexing here with Near and SubQuery. Super excited to be here. You probably noticed we're recording as well. And great to see a number of people, some familiar names as well. So great to see that. So let's jump straight in, jumping to the next slide here on the agenda. The workshop is about 25 minutes long, where we're going to go through four main points you can see on screen. The first one, we'll talk a little bit about the problem that we're trying to solve, and then we'll see how SubQuery approaches this solution. We'll jump into a quick demo as well, so if there are any programmers on the call, feel free to follow along as well. It will be a live demo, so fingers crossed that it works. I did test beforehand, so I will see how that goes. And then we'll have Q&A at the end, some discussions as well. However, if you do have any questions, feel free to type them in the chat window as well. So let's jump straight to it. First of all, what are the challenges that developers are facing when building amazing dApps within the Near ecosystem, right? Well, what we've found is that developers are asking, where and how do I get blockchain data from to power all the apps that I'm creating? And you probably think, well, you just get it from the blockchain, right? But it can be quite tricky in terms of how we do that. So this is where SubQuery comes in as an end-to-end blockchain indexing solution. And we'll start off with step 1 out of 3, where we've got this open source SDK data indexing software that anyone can download, use, and start grabbing data from the Near ecosystem blockchain. We've also got a managed service as well, because once you download the code and you start grabbing data, you're running on your computer, right? Local host. Of course, you can host it, say, on Google Cloud, maybe AWS, but we've also got this managed services just for your convenience as well. And then the third piece on the right-hand side here is that we've got this decentralized marketplace. So what you can do is if you've got a project, we've got indexes in this marketplace that can help take your project, index it, get the data, and then basically sell the data to consumers, right? And even yourselves, you guys, people on the call can become indexers and basically generate some sort of or earn rewards from indexing data on the blockchain and making it available to those who want to make use of it or consume it. So that's what SubQuery is. And a lot of people ask, well, why use SubQuery? What are the advantages or the benefits? Well, there are a number of benefits. The first one, as mentioned, being open source. However, it's also quite easy to use because we do have this Dockerized container environment where you can actually get up and running within minutes. And hopefully we'll show you that in the demo very shortly. It's also very simple to use because there are literally 3 files that you have to modify in order to get a project up and running. And again, we'll take a deeper dive very shortly. It's also very customizable because you can specify the exact data that you need from the blockchain to power your application. And when you specify just the data you need, it actually becomes quite fast and lightweight. It's also feature rich. There's lots of things you can do with the SubQuery SDK. One example was historical state querying. Another one is if you have an ABI, um, the smart contract address, an ABI file, you can actually give that to the project, and the project will go ahead and create all the functions for you from the ABI file. So it makes creating a project really fast. It's also real time, so you're actually indexing in real time as the blocks come through and they're generated as well. So there's very little lag. And one of the main benefits actually is this multi-chain feature where when you create a project, you say, what blockchain do I want to grab the data from? So of course, in being in the Near ecosystem, you can grab data from Near, but what you can also do is actually specify data from other ecosystems as well, such as, say, other EVM chains, maybe Cosmos, Algorand, Polkadot, etc. And you can bring all this data in this one single project, effectively storing the data from different chains into one database. And what happens is that you can almost have what is termed this unified API, so to speak, making it nice and simple to get the data that you need. It's also very flexible, as mentioned earlier, where you can host in locally, managed service, or even in the decentralized network. And of course, the last one here is it's EVM compatible, because we know that the EVM Ethereum space and ecosystem is very large. So these are some of the benefits here of using SubQuery. And on this next slide, you can see some of the supported networks. Across the top here, we've got the EVM networks. And then, of course, Polkadot on the right-hand side here, Cosmos, Algorand, and of course, Near here. And we want to help grow the Near ecosystem as well, helping the developers get the data that they need. Okay, so that was a very quick overview. Let's now jump into uh, the Near Starter project as an example. You can go ahead and scan this QR code if you want. Otherwise, we can navigate to, I'll put the link actually into the chat window as well, just for reference. It's basically a link to the SubQuery GitHub repository in the Near folder. So I'll copy this out. Let me put it in the chat like so. And this is the starter project that we're going to use when creating our project, right? So as mentioned, if you are a coder, there are some prerequisites required, and you probably have number 1 and 2 already. So Node.js, you'll need that. You can install this very quickly with brew install node if you're using brew. Otherwise, download it from the website. And same with Docker as well. The last one here you may not have, because this is the actual subquery command line interface, or CLI, and you can store this very easily with npm install -g for global at subql/CLI, and I've got this in the chat as well, just for your reference. And once you've got all these three, what we can do is start creating a project. Now, as mentioned, it is simple. There are only 3 steps involved, effectively modifying 3 files. Right? Number 1 is we want to define what we call the shape of the data we want to index. So what kind of data do we need? And we can specify this in what we call a schema file. Number 2, we then go ahead and look at the manifest file, and we configure the endpoints and the filters. Because once we know what data we want, we need to know where to get it from. And then the last step there, step number 3, we want to transform our data with the mappings file. And this is where a lot of the coding happens. We can transform, we can aggregate, do all sorts of things within the actual data itself to get it to a state to drive our, say, mobile app, for instance. All right, so that's a bit of the background there. So let's go ahead and take a look at this project overview. The goal is we're going to index in real time all price submissions from the priceoracle.near on Near mainnet. And again, a couple of references here, the Near Price Oracle example project, which I'll also put in the chat here. So this is the project that we'll be running. There we go. And there's a link to a quick start guide that I'll be following along as well. and I'll share this on the next screen. Okay, so let's go ahead and jump in. Let me go across to VS Code here, and again, I'll just give you a brief intro here to our documentation website here, academy.subquery.net. On the left-hand side, if I go to specific chain and then scroll down, you'll see we've got near. Click on near, and this is what we'll be working on. So I'll refer to this very frequently, but first of all, let me jump into VS Code. And again, if you do have VS Code up and running, you can try this out, where what we'll do is we're going to run SubQuery init. So this is the very first initialization command. Let me call near demo project, like so, giving it a name, hit enter. And then what's going to happen is I'm going to have to choose a network family. And you can see we've got a list here of Algorand, EVM, Cosmos, etc. I'll select near, and then I'll select the near network. And then I can choose different options here. The near price oracle example, this one here is what we're going to be building. But if you select this one here, it's basically the end state, the code, the answer, so to speak, right? But I won't choose that because I'll choose the starter project first and I'll build it. So let me try this. And then automatically on the right hand side, you can see we've got the scaffold or the structure of the project all created for us. And this makes our job a lot easier as well. So back to our command line here, we need to provide an endpoint. If I just hit enter, the yellow default will be accepted. So let me just accept the default here. Just for demo purposes, I'll just select and agree, and then that's it. The very first thing after this is I want to cd into my folder, right? So near demo project. And as always, with every single project, you want to install the dependencies. So I can do this by going yarn install. This will take maybe 30 seconds depending on your internet connection. While this is loading, let me just click on the schema file, because remember I said that this was step one, where we define what we want to index. So here we've got 3 entities, and we're indexing fields such as author, hash, timestamp, signer, receiver, etc. Right? So this is how we define them. And then the second step, you may recall, is the manifest file, which is the project.ts file. And this is the configuration. So if I scroll down, you'll see that I've got the endpoint that I chose by default. So this is where I'm going to get the data from. I've also got a start block as well. So if this is 1, it'll be the Genesis block. At the moment, we've selected about 80 million for this particular example here, and this will change shortly as well. And then the last file is the mappings file, which is in the sources directory, mapping handler. And this is where a lot of the coding takes place, right? Okay, so you can see that the dependencies have loaded, which is good. Now, the next step, what I want to do is if I jump back into the documentation, this quick start guide here, number one, I want to update my schema file. Right, so what I'm going to do is copy this out here. We've got 2 entities. One is the Oracle entity, where we're indexing the creator, the block height, the timestamp, and also the price as well. So let me copy this out and paste it in our schema file. So I'll just replace, select all, delete, and paste this in and save it. And what this means is that you'll see we've got asset ID, which is of type string. We've got price of type integer. The exclamation mark means that it's mandatory. What's also interesting is that I've got this field here called Oracle that is of type Oracle, which is this object up above. So we can actually have this kind of one-to-many relationship, so to speak, where a field can be of type of another entity that we've defined as well. And again, this relates directly to database tables and how databases can link or reference other tables too. So this is the schema. And of course, when you're designing for your own project, you could design this and specify the type of data that you want to grab. After this, let me scroll down. We want to update our manifest file, right? So I'm going to change the data sources section because I want to copy this here. And what this is saying is that we want to index from block 84 million. And we've got some filters that what we're saying is that when this filter criteria is met, trigger this function or this handler, right? So when we find an add Oracle method name on the near blockchain, stop and then call a function called handle new Oracle. And it's same for the second handler when there's a report prices method, we want to filter on this, therefore call the handle new price handler. So let me copy this like so, and I'll jump into my project manifest file here. Note that a lot of the parameters above we don't need to change much. Usually it's just the data sources section. So I'm going to copy and replace all of this here. Just delete, paste, and save. And there we have it. Now the very last step before I go ahead and run this project is I want to go ahead and update my mappings file. So let me just copy this across and then I'll explain it in a second. So I copy this, go to my mapping handler, select all. I'm just going to do a straight replace, save. And what this is doing is it's importing a whole bunch of functions and types as well. And then I've defined two objects up above, new Oracle and new prices. But the interesting part comes down in my functions, right? I've got my handle new Oracle function. And if I put this to one side, you'll see that the handle Oracle function name corresponds to my handle new Oracle handler, right? So once this filter criteria is met, it will trigger this handler, which will trigger this function. And this function, what it does is it logs some information to the console, and then it'll go ahead and actually call this helper function down here. The second function, very similar, it logs some information out, calls a helper function, and then it goes ahead and actually gets the data from the blockchain and assigns it to our fields. All right. So that's pretty much it. Let me save this, and now I'll test this by first of all running yarn code gen to generate the types. And then I'll go and build the code by running yarn build. And the last one is to start Docker, which is basically the command yarn start Docker, like so. However, if I go ahead into my package.json file, I've also got a shortcut where I can actually run yarn dev, which will actually run the three commands in one go. So it'll run code gen, build, and then Docker compose and Docker up as well. So yarn dev is the quicker option, like so. Now what's happening in the background now is that it's going to pull down some images from Docker. You can see here, I've got three images, a Postgres database, the GraphQL engine, and also the SubQuery node. So this should go green one by one, so 2 out of 3. And once this finishes loading, what I'm going to do in the meantime is let's go into our documentation and I'll grab out a sample query. So just scrolling down here. Here is a sample GraphQL query that I can use. Let's copy this out. And I want to go to localhost. Let's go 3000, which is the playground here. And let's go paste, hit run. And you can see I don't have any data at the moment, right? But it's indexing in the background frantically. Hit run. Give it maybe another 10, 20 seconds. And there we go. Oh, it worked. So this is actually live data coming right now from the blockchain. We're grabbing the first 50 only. So you can see it's changing here, the ID, etc. Now you might be asking, how can I cross-check this, right? Well, one thing we can do is we can go to a Near Blockchain Explorer. Right, so let me go to say nearblocks.io, just an example here. And I can go ahead and grab this ID here. Let's paste it in here. We'll do a quick cross check. Let's go into the execution plan here. And it's actually the actions area here that we're looking for. So I'm looking for a price of 9,999. Is it in here? Oh, here we go. So 99996, and you can see there's 22 decimals, 22, 22. The asset ID is USN. So there's a match, and this is also coming from pythia.near. So that's the ID. The Oracle ID here is pythia.near as well. So there we go. Just a very quick example of how you can get your Near starter project, and this one here building an actual project for the Near Price Oracle using a Docker. All right, so let me jump quickly back to the slides here. Just a screenshot of what we saw before. The data matches what we saw on the Block Explorer, which is good to see. And again, this is a kind of project where it's supposed to help you get started to create your own project very quickly. So let's just go through a quick summary here. We looked at what is SubQuery and why you'd want to use SubQuery, some of the benefits. We looked at the 3 simple steps to create a project. Basically the 3 files that we saw, the schema file, the manifest file, and the mappings file as well. And then you saw a quick real-time example of indexing all the price submissions from priceoracle.near on Near mainnet. And it was pretty cool how it was indexing fairly quickly. Just a quick note on the SubQuery network, the decentralization and tokenization of the network is the next big step for SubQuery here, where you can completely decentralize your application stack and incentivize your community to help run your infrastructure as well. So if you do want more information, you can scan the QR code there. Otherwise, if you want more information, feel free to reach out on our documentation page or some of the links here as well. Feel free to contact me on LinkedIn. Also, jump into our friendly Discord community. People are always willing to help there. Let's open up the lines for any questions. Hope that was useful. Hope that you got a quick insight, a quick taste into how you can index very quickly data on the Near blockchain.